Hey guys, it's Willman here. I'm gonna take a little bit of time to kind of map out what our next unit is here in Algebra 1. First we're gonna go over some vocabulary, then we're gonna jump right into some examples. So I'm gonna apologize, this video is probably gonna be longer than all of the ones we have posted before, but it is gonna be necessary to watch the whole thing. So if you wanna pause it at certain spots, feel free. If you wanna take a little break, if you wanna watch it over the course of 2 days, you do that. Whatever works best for you, you make that happen. So our next unit is going to be over something called polynomials. And for those of you students that are wondering what exactly algebra is or what's at the heart of algebra, polynomials are right at the heart of that, okay? Polynomials are a big part of Algebra 1. They're going to come up again in other math classes later on, so it's going to be important for us to get a firm foundation before we keep moving. So a polynomial, by definition, wouldn't be a bad thing to write down. It's an expression that involves operations of adding, subtracting, multiplying, and non-negative integer exponents as variables. Looks like a lot of words going on there, right? Okay, let's break it down a little bit. Remember, an expression is something like this. You have terms, you got 2x, you got a 2, it's separated by a plus sign. That is an expression. That technically is considered a polynomial because it contains, like I just said, adding, and it contains an expression or those terms, okay? This is also an example of a polynomial. I'm going to do it in purple. Let's say 3x cubed plus 2x minus 4. This is another example of a polynomial, okay? So lots of variables, lots of numbers, lots of symbols. Notice there's no equal signs. There are no equal signs in polynomials. So polynomials is like the overarching vocab word, but as you guys probably know, with a lot of things in life, there are subcategories. So we're going to break this down into 3 subcategories. The first one is a monomial, okay? I don't have a good little trick to remember this one, but basically a monomial is a polynomial that has one term. So mono, that root usually means 1. So 2x is a monomial. 4x squared is a monomial, okay? Some of you are probably guessing this. Yes, Mr. Willman, that is correct. Binomial is the next one. That root or that prefix bi, just like a bicycle. Here's my little bicycle drawing here. Oh boy. Been a while since I was in art class. A binomial means 2 terms separated by adding, subtracting, okay? These are examples of binomials. And then finally, those of you that get the pattern, a trinomial or a tricycle. A tricycle has not 1, not 2, but 3 wheels. So a trinomial has 3 terms to it. Something like that would be a trinomial, okay? So again, the overarching idea is a polynomial. If it specifically has 1 term, we're going to call it a monomial. If it has 2 terms, we're going to call it a binomial. If it has 3 terms, we're going to call it a trinomial. What in the world are we going to do if we have this? Mr. Willman, you didn't talk about this one. What's this going to be, Mr. Willman? 1, 2, 3, 4 terms. I'm going to say, well, we didn't talk about it. If there are more than 3 terms, just simply call it a polynomial and make it a little easier for all of us, okay? So if there are more than 3 terms, just call it a polynomial, okay? All right, so that was the classification of polynomials. Let's move on to everyone's favorite part of math. Let's start doing some operations. So I'm going to say, I'm just going to write just some operations. We're going to cover adding, subtracting, and multiplying. So without further ado, let's get started. Let's do example 1. Let's do 3x squared plus 4x minus 5 plus x squared minus 5. You know what? Let's make that a 6. Okay? So this is going to be similar to some other things we've done in class before. Okay? This is kind of like the combining like terms unit that we covered either this year or probably last year sometime in math class, okay? All we are going to do is combine terms together that have the same variable and the same exponent. So we're going to combine like terms. We're going to combine all the x squareds together. So I see 3x squared, I see x squared. Remember, there's actually a 1 in front of that x squared right there. So if you take 3x squared plus 1x squared, you're going to get 4x squared. Okay, let's combine the x's. I see 4x. I see no x's over here. No x to the first powers. So how many total do I have? I got 4. 4x. Finally, let's combine the numbers with no variable, the constants. I see a minus 5 or a plus negative 5. And I see a negative 6 over here. And a negative 5 and a negative 6 is negative 11, okay? So we started off with a trinomial over here and a binomial over here, and we ended up with this trinomial right here. 4x squared plus 4x plus negative 11, okay? Let's try this second example. Let's try 4x cubed minus 2x squared minus 7 minus, let's do x cubed minus 3x plus 4x. We'll leave it at that. Okay, so the only difference between this problem and the problem we just did before was that there's actually a subtraction sign here, okay? So some of you probably think the subtraction sign isn't really going to change a whole lot. Maybe it's only going to affect this first number. But remember, there's actually a number to the right of this negative. There's actually a negative 1 here. And what do we do when we have a number right outside of parentheses? We need to distribute, okay? So here's a point in the video when you can do two things. Number 1, you can distribute and rewrite that whole trinomial, or option 2, you can be careful when subtracting. Okay? So I'm going to choose that second route. I'm going to be careful to make sure when I'm subtracting, I take that negative along with me. Okay? So that is how we are going to tackle adding and subtracting polynomials together, okay? My tip is when adding, you can just simply combine the like terms, combine the powers that are the same, x squareds with x squareds, x's with x's, constants with constants. My tip for subtracting, wouldn't be a bad idea to distribute to each individual term before you combine your like terms. But if you think that you can be really careful and do it without doing that mini step, you go for it, okay? Always double check your answers. So that is going to be adding and subtracting polynomials. Now we got to go to multiplying polynomials together, the fun part. Here we go.